Okay, so here's a little video on significant figures. Sorry, I was not at school today. Um, so the rules for determining which digits are significant are listed there, A, B, C, and D. Oh, just so you know, the reason we even are interested in significant figures is because we're very limited on our ability to measure very precisely. Usually 1 or 2 decimal places is about the best we can do. And so if we're doing math using those measurements, we can't assume, we can't even depend on, a lot of times when you're doing multiplication division, you get whole bunches of digits and then you have to round them off anyway. So we just have to assume that we can't be more precise in our calculations than we are in our measurements. So hopefully that helps a little bit. So if you've got some digits and you're trying to see if they're significant or not, here are the rules. If it's not zero, you should count it. If it's a zero between numbers that are not zero, you should count it. If it's a zero before all other non-zeros, you should never count it. And if it's zero after other non-zeros, you should count it only if there's a decimal point somewhere. Doesn't matter where. And notice that rule D does not say that all zeros after the decimal points are significant. There's some garbage right here that I need to get rid of. Okay. So here's a short table. Here's 1, 2, 3, 4, 5, 6, 7 numbers. And we want to know how many of them are significant. Well, rule A, if it's not zero, it counts. So there's 2 in that number 81. Which ones are they? Well, it's the 8 and the 1. On the second one, there are 3. Right? None of them are zeros. All 3 should be counted. 2, 6, and the 2. All of those count. On number 3, the 0.007, notice none of those zeros at the beginning. Those are all zeros before non-zeros, so they should not count. So we're left only with the 7, so we have 1, and it's the 7. On this next one, we got the 5, the 2, the 3, and the 8. Those are all non-zeros, so they all count. There's 4. And those 2 zeros are trapped between non-zeros. See, between non-zeros, we count them. So 1, 2, 3, 4, 5, 6. All 6 of these count. So the 5, the 2, the 0, the 3, and the 8. They all count. On the next one, 380.0, the 3 and the 8 both count because they're not zero. And the other 2 are zeros on the after all the other non-zeros, right? We've passed all the non-zeros, the 3 and the 8. So those 2, if there's a decimal point, we're going to count them. I see a decimal point, it doesn't matter where. So all 4 are significant. 3, the 8, the 0, and the 0. They're all significant. And then on this next one, number 6, I believe it is. 3, 4, 5, yep. We're going to count the 1 and the 2 because they're not 0. We're going to count the middle 0 because it's between non-zeros. So there's 3. The zeros at the beginning don't count either one of those. And the one at the right will count if there's a decimal point. I see a decimal point, so we have 4 Sig Figs. And they are the 1, the 0, the 2, and the 0. And on the last one, it looks to me like the 7, the 8, and the 8 should all 3 count. Those zeros are after non-zeros. That's rule D. Zeros after all non-zeros. It's significant only if there's a decimal point. I don't see a decimal point. You can't assume a decimal point. It has to be written there to count. I don't see one. I see 3 Sig Figs, the 7, the 8, and the 8. Okay, so if we want to do calculations, add and subtract, you keep the fewest number of decimal places. So 81 plus 26.2, I punch that in my calculator, and I get 107.2. But I should only have 0 decimal places because the 81 has no decimal places. So I'm going to round this one to 107. On the following one, 78800 minus 0.007. If I do that on my calculator, I get the answer of 78799.993. But my first one has no decimal places, so I'm going to round this to no decimal places. So it looks like 78800. And I know what you're thinking. That's the number we started with. Well, look how little we subtracted off of it, and we weren't real precise on those last two zeros. That last zero, anyway, it might have been 78800.9, which would have made it 01. You know, you just don't know what was there. So, well, actually, it had to be less than 0.5. So that's perfectly okay that it's the same answer as what you started with because you're subtracting off such a small amount and there's no decimal point. So multiplying, dividing, we're going to keep the fewest number of total sig figs. So 81, times 26.2. My calculator says 2122.2. But the 81 has only 2 sig figs. The 26.2 has 3. 2 is fewer than 3. So my answer has to have just 2 significant digits. So I'm going to keep the 2 and the 1. What do I do with the rest of them? They become zeros. And I don't want a decimal point because then that makes them all significant. So that's the way I need to write it, to have 2 sig figs. Or if you prefer, which you probably don't, 2.1 times 10 to the third. Oops. That gets rid of those non-important zeros. So that's one way you can do it. If you like scientific notation, which you should. You should get used to that. And finally, the 26.2 divided by 380.0. My calculator says 0.068947368. So I need to round this to just 3 significant digits. And again, the zeros at the beginning do not count. So we're looking at the 68 and the 9, and then I look at the next number to see if I need to round that 9. It's a 4, so I don't need to round the 9, even though there's a 7 after, which would round that to a 5, but you only round once. So don't worry about that 7. We're going to just not worry about any of that. I'll highlight that, say don't worry about that. And so our answer is 0.0689. Oops, that's not a 0. Or, if you want rid of those zeros, 6.89 times 10 to the minus 2. So there you have it. I hope this helps. And hopefully I'll see you tomorrow or sometime.